based on those examples and our earlier slide with the bullets, we can implement unify like this. Here we've got two type arguments, and there's the interesting work where the first one is a type variable and all the other cases where it's not. In those other cases, it depends on what t2 is. So if it's a type variable, this is where we swap it around. If t2 is numt and t1 is not a variable, then it must be numt as well. That's when we succeed, otherwise we fail. Bool t needs bool t. If t2 is an arrow t, then maybe t1 is also an arrow t. And if so, we recur with the arguments and the result types separately. Otherwise, if they're not both arrow types, then we complain again. That leaves these dot dots here, so let's concentrate on that part instead. When we have a type variable, remember the first thing we can consider is whether it's already assigned or not. And so we take the box, the is box inside that type variable, look at what type we have inside, if any. If we already have a type assigned, then we just try again with that type that we've assigned to the type variable. So that's why there's a recursive call to unify here. Otherwise, this type variable is not yet constrained. It doesn't yet have an assignment. So then we need to look more closely at t2, and we resolve it to get the most information we know about t2 so far. If that resolved type is the same as t1 already, then we haven't learned anything and we want to succeed. And you'll notice that the check here is not equal, but eq. eq question mark checks object identity. It tells us if we modified this type variable, we would also be modifying that type variable. And that's key here. Instead of equal, we need to check to make sure that to check whether t3 is exactly the type variable t1. And if it is, we haven't really learned anything and we just succeed. Otherwise, we need to make sure that t1 does not appear in t3. That's the occurs check. So if t1 does appear in t3, then we need to fail. Finally, if all those things fall through to here, then that means we know that t1 should be unified set to that t3. So we put t3 in a sum and install that into a box and succeed. We've learned some information. We've added an equation into our type variable, and that will be available for use in later unifies. Our helper functions for unify are resolve and occurs. Resolve takes a type, and if it's a type variable, and if that type variable has been set to some other type, then it returns that other type, possibly recursively resolving it. Resolve doesn't have to look inside of arrows because resolve is only used to check whether some type variable is equal to specifically some other type variable or some simplified type. The occurs check, on the other hand, does need to go inside of arrows and things like that. If you're looking for some type variable r in some other type t, and that other type is a num type or a bool type, then clearly it doesn't have a type variable. But if it's an arrow type, then it might have a type variable in the argument part or in the result part. And if the other type is a type variable itself, then maybe we found the one we're looking for, and we detect that using eq, or that second type variable is assigned to something already, and so we need to effectively resolve it, but the resolve is sort of built into occurs also to check whether r occurs into t2. Notice that we don't have to consider the type that the case that r has been assigned to a type itself, because we only use the occurs check when r is not already assigned to a type.